तो हम चाहते हैं कि वो अलग अपना बढ़िया से काम करें।
Hello, Sudhatu. Good evening. Welcome to class. I'm just waiting for a while so that others may come. I'll just wait for another 1 or 2 minutes because once the class starts and people pour in, that's really difficult. Okay. So were you there in the previous class of the same topic? That is the production function. With one factor we have studied. Were you there, Sudhatu? Okay, so it will be a little difficult for you to catch, but anyways, we will be doing another part of the same topic. So you will just catch it. It's something very much like that only. Good evening, Darshna. Welcome to class. I'm just waiting for the students to come. Just 1 or 2 minutes I'll be waiting. Okay, then we'll start off. Okay, let's now start. Alright. So today we are going to study about the producer's equilibrium. So Dhatu, the topic which we are doing these days is based on the determining the equilibrium level of the producer. Equilibrium means the best point. So hello, Darshna. Darshna. Hello, Darshna. Hello. Hello, Sadatu. Can you hear me? Can you all hear me? Sadatu, Darshna, Samu, can you hear me? Muhammad, am I audible to you all? Okay, alright. Darshana is saying there's no voice. So, Darshana, is that fine now? If the problem is persisting, you may just log out and log in again. Okay? Then it will be fine. Good evening, Samu. Good evening, Muhammad. Welcome to class. So, today we'll be studying about the equilibrium level of the producer. So, for a producer to be in the equilibrium or to be at the equilibrium point, he has to incur minimum cost of production and the maximum of profit. Then we can say he is at the most profitable point and he is going to get the best of his resources, out of his resources. Alright, so that is the producer's equilibrium. So how do we arrive at this? That we are going to study. And what is its significance? That also we are going to study about. So if you remember, in the previous classes we have done the production function with one variable factor. Darshana, I think you were there in all the classes, so you must be knowing about it. Samu, you were also there, if I'm right? So production with one variable factor. So what was the variable factor which we used for our analysis? Was it land, labor, capital? What was that? Yeah, factors of production I'm talking about. No, and not entrepreneurs. It was actually the labor. The labor factor of production is the factor which is variable. Variable means the factor which can be changed even in the long run. Okay? So if we are in need of more laborers, we can arrange for them. If we need less laborers, we can do away with some laborers. So we can make adjustments as per the need even in the short term. Short term means a period less than a year. Okay? So it can be 3 months, 6 months, 1 month, 9 months, 12 months, whatever. It depends on the firm. Because capital and land cannot be varied in the short run. Okay? So that's the thing. So now, coming to this, the production depends on how many things? Production depends on the, or rather what are the factors of production? The first is land, the next is labor, and the third is capital. Okay? So land, labor and capital are the three factors of production. So presenting this in the form of an equation, we write Q is equal to S, K, LA and L. Alright, that is production or output. Q stands for the output. Output is a function of K for capital, LA for land and L for the labor. Okay, it's a function of capital, labor and land. So that is what is the meaning of this. This is the mathematical equation to represent the same. So now going ahead, in the short run we can only change this labor, the quantity of labor. We cannot vary land and we cannot vary capital. But when it comes to long run, in the long run, labor and capital are the two factors which can be varied, which can be changed over a period of time. They can be increased or decreased as per the need. Alright, so now we are going to do the analysis of these two factors of production and their impact on the production. So now talking ahead, now what is the cost of labor? Does labor comes free to the manufacturer or is there any cost involved? labor is free of cost, or it has got some value, or rather some cost to the firm? Siddharthu, Samu, Muhammad, Rafiq, Darshna. What do you think? Labor is free, or we have to pay something to the labor? No, it's not free, Darshna. We pay wages to the labor, isn't it? So wages is the cost for the labor. Okay? Wages. That is the cost to the labor, of the labor. Then talking about capital. For capital, we have to pay the interest. If we are using our own money, or sorry, I'll start with this. If the manufacturer is short of money, then what will he do? He will borrow money from the market. He will take money from the market, in return of which he will have to pay the interest. Isn't it? So interest is the cost for the capital, and wages is the cost for the labor. Okay? Is it fine? Siddharthu, Samu, Muhammad, Rafiq, Darshna. So far clear? Okay. So now suppose the manufacturer uses his own money. He puts his own money into the business. He invests out of his own resources. Then what is the cost? Then again the cost is interest. Now how? Because the manufacturer is using his money into the business instead of keeping it in the bank. So the bank money, the money that is, if we are going to keep the money in the bank, again we will be earning interest. So he is letting go of that interest, and instead he is investing the money into the business. So again the cost for that is interest for him. The bank interest, which he is not getting because he is investing the money into the business. So in both the situations, he is going to incur interest as the cost for the capital, whether he invests his own money or whether he takes money from the market. In any case, the cost for the capital is interest. Alright? Is this thing clear to you all? Okay, Samu, like suppose if the manufacturer invests his own money into the business, he does not lend from the market, then what is happening is he is investing the money into the business, but he is not keeping it in the bank. So when he is not investing in the bank is not going to pay any interest to him. So again, what he is doing is he is letting go of that interest. He is losing that interest because the money is invested into the bank. So that interest which he is not earning because of non-investment into the bank, he is incurring the cost of capital as the interest. Okay? And if he is raising the money from the market, then directly he will have to pay the interest to the borrowers. So in any case, the cost for the capital will be interest for the manufacturer, and for labor it will be wages. So these are the two things on which our analysis will be based. Now, if we have to determine the equilibrium level for the manufacturer, we have to consider these two things, wages and interest, very carefully. And every producer, he is bound by a budget. Like a consumer has a budget, similarly a producer also has a budget for which he will be using for the amount of money that he will be using in the business. Now for this concept, we need to know two more things, that is iso-cost and iso-quant. Okay, iso-cost and iso-quant. These are the two things on which this whole analysis is based. Now, in this one, this iso means the same. So isocost means same cost and isoquant means the same quantity. So these are two different types of graphs which gives us the same cost and same quantity. Now isocost is a line which shows the cost of the different combination of inputs which a manufacturer can use for manufacturing a desired level of output. Now, suppose this is a graph. Now, in this graph, there is a line like this. This is y-axis. It's looking like x only. Just a second. This is y-axis. I'll draw it again properly. And this is x-axis. So this x and y-axis. Repeat. The full form of Q is equal to SKL. This is Q stands for the output. Q is the output. S means the function of. K is for capital. L is for land and L is for labor. So that means output or production is a function of capital, labor and land. It means it depends on these three things. Okay? Is it clear, Rafiq? So, coming back to this, this line is going to show us the cost of the various. No, capital is denoted by K, not C. Okay? In economics, we denote it with the help of K. C is also not wrong, but technically it's K. So this line is going to show us the cost of the different combinations of wages and interest. Over here I will write I. I is for interest on capital, and over here it will be W. W is for wages. So this is the line which shows the combination of combination of these two. Now, suppose the producer has a budget of $200. Okay. Now he will be this line, like any combination on this line will be equal to $200 only. Suppose I take this combination. It may be 4 units of capital and 1 unit of labor. The total cost for this combination will be $200. Okay. Now I go back. I take another combination. It may be 3 units of capital and 2 units of labor. Again, the total cost for this combination will also be $200. The total budget that is there. Suppose next maybe 2 units of capital and 4 units of labor. So again, the cost of this combination should be $200. Is it clear? So it means this isocost is a line which shows the same cost. I mean the different combination of goods which we can use, and the cost of this combination will be the total budget available to the consumer. Sadatu, Muhammad, Darshna. Is it clear? You did not answer, so I am asking you. Okay. So this was isocost. Alright? So isocost means the same cost. A line which shows the same cost of the different combinations of inputs. If you define it. Now, going ahead with the second thing, that is isoquant. Now, what is this isoquant? This isoquant is the locus of Locus is a mathematical term which means like when you join the different points, that is the locus. So this isoquant is the locus of the different levels of output which can be manufactured by a firm using the given combination of inputs. Okay, so suppose this is one isoquant. So isoquant, this may be for 200 units of output, not $200, not in terms of money. Now we are not talking about money. Now we are talking about 200 units of output. So this is 200 units of output. Now any combination on this 200, any combination that we are going to pick is going to give us the output of 200 units only. Or what I'll do is I'll change this figure. Instead of 200, let's make it something else. Say 400, otherwise you'll get confused. So now, if I take this point, so it will mean using 3 units of capital and 1 unit of labor, we can manufacture 400 units of output. Okay. Now, next one, maybe with 2 units of capital and 2 units of labor, again we can get 400 units of output. Going forward, with 1 unit of capital and 4 units of labor, we can manufacture 400 units of output. Okay, so it means whichever combination we are going to pick, the total outcome which we will get is the 400 units of output. Alright, is it clear? Siddharthu, Samu, Muhammad, Rafi, Darshna. Alright, so that is the difference between an isocost and isoquant. Isoquant talks about the quantity of output and isocost talks about the budget or the rupees, rather budget which is available with the manufacturer. It talks in terms of cost. It shows the different combinations which will fall in the budget of the consumer, and this isoquant shows the various combination of inputs which we can use to get the desired level of output. So this is an isoquant, and as we move ahead, as we move upwards, like if I make an isoquant over here, that would mean a higher quantity of output, maybe 500 units. And as we go down lower, means the closer we are to the origin, this is the origin, a graph which is closer to the origin would mean a lower level of output, and a graph which is away from the origin would mean a higher level of output. Okay? So every firm aims at the higher graph, because higher graph would mean more output. So everybody wants to manufacture maximum at the minimum cost to attain the level of equilibrium. So that is what is shown with the help of this isoquant. Can I go ahead now to the PPT? Okay. So these are the two things which help us in analyzing the equilibrium level of producer. Now, what is producer equilibrium? The ultimate aim of any firm is to earn the maximum profit possible, and producer's equilibrium is the situation of profit maximization. It is the point at which the profit becomes maximum for the producer. So at equilibrium, the firm has the maximum level of output being produced and earning the maximum profit out of the same. So it is the equilibrium level of output which the producer will produce at the minimum cost and sell to earn the maximum profit. Means the cost should be minimum and output should be maximum. That is the point of equilibrium for the producer. So every firm aims at that only. Now, to explain the producer equilibrium, both isoquant and isocost has to be analyzed. The producer equilibrium can be explained graphically with the use of both isoquant curve and isocost line. So we need both of them when we are studying about the equilibrium level of the producer. So it is attained at the point where the, 1 minute. Coming back to this one. Now what is the role of these two in determining the equilibrium level of the producer? Suppose this is an iso cost line. I'll draw another one. This is too bad. Suppose this is the iso cost line and this is an iso quant. So you can notice that at this point, let us say this is point P. So at point P, the isocost line is touching the isoquant curve, isn't it? So this is the point of equilibrium for the producer. The point at which the isocost line touches the isoquant curve is the point of equilibrium for the manufacturer or producer. Or we can say the point at which the isocost line is tangent to the isoquant curve is the point of equilibrium for the manufacturer. Tangent. Tangent is a mathematical concept. Tangent is a line which touches a circle at a single point only. So over here also. This is in the shape of a semicircle. So this isocost line touches it at point P, and so point P is the point of equilibrium for the manufacturer. Okay? So coming back to PPT, it is attained at the point where the isocost line is tangent to the isoquant curve in the graph. So yes, Samu, we need it for the for calculating the profit of the firm. So, not profit actually, for like projected production. Every firm has to have an idea of what will be its future needs so that it can arrange for the necessary things. So for that analysis, we make use of this producer's equilibrium. How much may be the equilibrium level of output, what arrangements, what inputs, what quantities are needed, what amount of capital is needed, what amount of labor will be needed, so that we can all decide in advance. So this is the description of isoquant. It refers to equal quantity. So isoquant line is the locus of points showing the combination of factors, example labor and capital. This gives the producer the same level of output. It reveals the combination of inputs to get a quantity of output. Slope of the graph gives the marginal rate of technical substitution. Okay, this is another concept, marginal rate of technical substitution. This is calculated with the help of this formula. MRTS is equal to W upon R. This W stands for wages and R stands for the rate of interest. So This is the formula for calculating the marginal rate of technical substitution. Now what is this marginal rate of technical substitution? It is like the rate at which we are substituting the labor for capital. Means we are giving 1 unit of capital and we are increasing the labor by 5. So that may be the equilibrium level for the, that is the calculation of MRTA. I'll just show you in a graph, in a table. This is the output Q. This is the capital, units of capital. This is the units of labor, this column. So output 1 unit, 2 units, 3 units. Okay. So capital is, initially we are using 10 units of capital and 5 units of labor. Now we are using, this is 10. Now we may be using 9 units of capital and 7 units of labor. Next, 8 units of capital and 10 units of labor. Okay, to get the desired output. So in this case, the marginal rate of technical substitution will be the wages upon the rate of interest. Like if the wage for one worker is 20, so if there are 5 workers, it's 5 into 20. 5 into 20, it will be 100. Cost of one labor is 20, there are 5, so it will be 100 upon the prevailing rate of interest. Like suppose the rate of interest is 2%. So we are using 10 units of the capital. So that would mean 10 into 20. 10 into 2, sorry. 10 units for capital and 2 is the rate of interest. So what answer we get? We get 5 as the answer. So we can say the marginal rate of technical substitution is 5. Okay. Okay. That is the formula, wages upon R. And wages means the wage of one worker into the number of workers, and rate means the rate of interest. So now, going ahead, this is an isoquant. This is the Q, the desired level of output. This is for labor. This is for the units of capital. Now also cost. It refers to the equal cost. It is the cost of purchase of two factors, capital and labor, of production in a budget. So ISO cost line shows the locus of points showing the combination of inputs that can be purchased with the available budget. Locus means the connecting line. So the slope gives the ratio of wages and the rate of interest. Slope is W upon R. It is very similar to the marginal rate of technical substitution. We don't need to go into the details of slope. We just need to know till third point. So this is a diagram of an isocost line. This point means 8 units of capital and 0 units of labor. This means 6 units of capital and 3 units of labor. 4 capital and 6 labor. 2 capital and 9 labor. And this point means 0 units of capital and 12 units of labor. Okay, so it's an isocost line. Whichever combination we will take, the cost will be the same. It will fall in the budget of the consumer and it will be similar. It may be like fixed 50 units, $50. So for every unit, every combination, it will be $50 only. Okay, is it fine? So far everything clear? Isocost, isoquant. Rafiq, Muhammad, and Sadatu. Okay. Now produces equilibrium. It is attained at the point where the isocost line is tangent to the isoquant curve. It is the point where the isoquant curve just touches the isocost line. It doesn't intersect the isocost line. It does not intersect. Rafiq, this is business law, but I am teaching this topic because this topic was like left uncovered in the previous class. Okay? So that is why I am taking this topic. This is not business law, this is actually managerial economics. The class is of business law. We can adjust business law in some other session. Okay? So slope of the isoquant curve and isocost line are the same at this point. Means the point of equilibrium, the point at which the two things touch each other, the isocost and isoquant. At that point, the slope of these two are equal to each other. So you can see in the chart, marginal rate of technical substitution is W upon R. So this is the graph Y. This is the isocost line. This is the line which shows a figure which shows the cost minimization. This is the target of every firm. Now profit maximization is done by two methods for a firm. Rafiq, you can get this answer from the coordinator at iimts.com. Okay? Our task is to teach only. We cannot help you with these things. You consult the coordinator. You might get the most appropriate answer from them. So, there are two methods for this approach. One is this method which I have explained, and the other is marginal revenue, marginal cost method that we can do in another class. Okay. So we are done with one method. We cannot do everything in one class because it will be really confusing then. So now there is an example with this. There are four isocost lines: AB, CD, EF, and GH. Okay, there are four lines, and this is the isoquant of 400 units of output. The output is 400 units. So in this isoquant and isocost, they are touching each other at point Q, or it is the point at which the isocost line is tangent to the isoquant curve. So this Q is the equilibrium point for the producer. So he can manufacture Q units of output using ON units of capital and ON units of labor. You can see ON and ON. So this is where he will attain his equilibrium point. This is the point for which he should aim. Alright? Now suppose why he is not taking point S or R or L or P? Because at these points, firstly, they are intersecting each other. The isoquant curve and isocos line, they are intersecting. Intersecting means cutting each other. So that is not the point of equilibrium. The point of equilibrium is when they are tangent to each other. So at these points it is cutting. Then moreover, this point R and S would mean a higher cost to the firm, and point L and this point would mean a lower level of output for the firm, something below the equilibrium point. So that is why we will not go for these combinations. We will choose this one only, the point Q. Now this is the explanation to this one. In the graph above, CD is the isocost line that is tangent to the isoquant curve 400 units at point Q. So the firm employs OC units of factor Y and OD units of factor X to produce the 400 units of output. In the graph, any point below Q on the isocost line AB is desirable as it shows lower cost, but it is not attainable for producing 400 units of output. And points R and S above Q on isocost line GH, EF show higher cost. As I told you, these points will show higher cost, so we cannot use them. And these would mean lower level of output. Then you can see this point S is lying on EH line, EF isocost line. So that means a higher cost to the firm. This point R is on this line, that is even higher. So it's better to choose this one. And any point on this line AB is not desirable because that would mean a lower level of output, not 400 units, less than that. That is why we are choosing point Q. These are unattainable by producer with CD budget. Hence, point Q is the least cost point for producing 400 units of output with OC units of factor Y and OD units of factor X. So, point Q is the equilibrium of the producer. At this point, the slope of the isoquant is equal to the slope of the isocost line. Alright, you can just read this. If you have any doubts, please tell me. So I'll just go ahead now. This is the second method for calculating the equilibrium. This we won't be doing today. So that is all for this from this part. Now I'll show you some videos which will help you. Just a minute. Please watch this, everybody.
Alright, so today's video actually starts chapter 3, which is the behavior of the firm. So we're trying to understand how firms make certain decisions. This is similar to what we learned in chapter 2, right? So in chapter 2, we understand how consumers behave. Now we're just trying to understand how firms behave and how they make certain decisions, alright? And we're going to use the isocost and the isoquant to help us understand this. And of course, we always begin by asking ourselves, so what does the isocost and the isoquant mean? Alright, so let's explore that into further detail. Let's begin with the isocost. The term iso here is actually a Greek word that means same. So the isocost basically translates directly into same cost. It is a graph that shows all the combinations of inputs given the same cost budget. Notice that the word same is in the definition of the isocost, and that's why it's called the isocost, right? So when a firm wants to produce certain goods, it's going to need some resources, okay? And those are the inputs that I'm referring to. In general, we're going to take a look just at two types of resources. We're going to take a look at capital, which is denoted by a capital K, and labor, which is denoted by a capital L. And to employ these kinds of resources, the firm is going to incur some kind of cost, which we denote as C0, C1, or C2, right? So this denotes the different levels of cost that the firm can actually incur. So for labor, we pay labor wages, right? So it's denoted by a capital W, and W here refers to the nominal wage. And as for capital, we actually incur a interest rate cost. Now, just let me explain why the cost of capital is actually the interest rate. It is because there is an opportunity cost of not putting this money into the bank to earn that interest rate. Instead, the firm is taking this amount of money and putting it into machines, vehicles, stuff like that to create those goods. That is why the opportunity cost of capital is actually the interest rates. Okay, so I can actually represent the isocost in a mathematical equation as well. It will be the total cost is equals to the wage rate times the amount of labor plus the interest rates times the amount of capital that we employ. Okay, to illustrate the isocost, we're going to need a graph with labor on the horizontal axis and capital on the vertical axis. It is going to be a straight line because it is we're actually referring to a linear combination of inputs, right? And the horizontal axis, the intercept, is going to be the total cost divided by the nominal wage, and this is the total amount of labor if 100% of my cost goes into labor. And this vertical intersect over here is the total cost divided by the interest rates, and it is the total capital that I can get if 100% of my cost is allocated to just capital. Alright, so I think this is pretty straightforward. Now the slope of the isocost is actually the wage rate divided by the interest rates. I'm not going through this in so much detail because I think by looking at all this stuff, you actually recall chapter 2's concept of the budget constraint. It is very, very similar to the budget constraint. And if you're going to compare the budget constraint with the isocost, let's take a look at what the budget constraint wants to do. It wants to go upwards, right? Because the consumer having a higher budget will actually let him buy more good X and good Y. However, for an isocost, he actually wants to move inwards. Why? Because to achieve a lower cost, you just move towards the origin, right? And that is what the firm is trying to do. It is trying to minimize its cost. We'll go into that later. Now let's talk about the isoquant. And again, iso here refers to same, and quant is of course quantity, so it means same quantity. So the isocost is actually a graph that shows all the different combinations of inputs that a firm is going to require to produce the same quantity of a particular good. Okay, just let me show you different combinations of inputs. So maybe we have 10 units of labor and 20 units of capital, or 20 labor and 15 capital, or 30 labor and 5 capital. It doesn't matter which one of these bundles, the firm can use this to produce X naught amount of goods, for example. So maybe X naught is say 15 units of X. If you're going to increase the quantity produced to X1 or X2, you're going to have to increase the amount of inputs that they put into the bundles, right? So in conclusion, all these bundles here can actually produce X naught amount of X. Okay, so that's what it means by the different combination of inputs that produces the same quantity of a particular good. So let's look at this in a graphical
Thanks for watching a sample of the Quickonomics online learning experience. We hope you've enjoyed it. We believe that true happiness lies in realizing ambitions and dreams. That's why we make our products specific to your needs, simple to understand and captivating, so that you can learn effectively while saving time, realizing those ambitions and dreams. The Quickonomics online learning experience is a range of supplementary lectures, tutorials, and exam solutions in the form of videos, which you can conveniently view anytime, anywhere. Watching our videos before and after your regular lessons at school, we aim to give you joy in learning and build academic confidence at the comfort of your own relaxed learning environment. So how can you begin? We welcome you to purchase Quickie Dollars to redeem the videos for full access to the Quickonomics online learning experience. Thank you for starting with Quickonomics.
Okay, that is uh, that is one video. Now there's another one which I'll show you, that is based on ISO quant and ISO cost. Okay, just watch it.
Okay, so here what I'm doing is I am connecting all these points, or putting all these coordinates, K and L, in an X and Y plane that has L in the horizontal axis and K in the vertical axis. So here's our first point, point A, 20 capital and 125 labor. All right, so this is A. And here's our point B, 50 and 50. Here's our point C, 100 capital and 25 labor. And here's our point D, which is 125 capital and 20 labor. Okay? And if we connect all these dots, let's do this in blue, we'll get a curve that is kind of familiar to you. I bet you remember a curve like this. This looks really similar to the utility functions or utility curves we were actually seeing in utility theory. And it's not surprised we're using the same formula, same form of the function, remember? So this is what we call an isoquant. An isoquant. And it has the same properties that a utility function had, which is the slope of the curve decreases in absolute terms as you go away from the origin towards the L, towards the x-axis, right? And as the number of units of labor increases, right, you go down here, and the number of capital units decreases, your slope of the curve is actually decreasing in absolute terms. And that's that's the fact that labor has diminishing marginal returns. And that's what we said before, right? We said that when you have very little labor, which is a D, and you want to increase your labor and decrease your capital, you can do this by replacing 5 units of capital with 1 labor, and this is right here, right? This is this point right here. But when you have a lot more labor, let's say at 50, it will take a lot longer, a lot more to actually replace that capital with labor. Right? At that point, you will need 75 units of labor to replace only 30 units of capital. So the fact that this isoquant has a diminishing, a smaller slope in absolute terms as the number of units of labor increases reflects the fact that labor has diminishing marginal returns. And the same for capital. As you increase the number of units of capital, the slope is going to get larger in absolute terms because you will need more capital in order to replace a lot less units of labor. All right? So we are going to, this is the curve we're going to be using in order to study production. Now, another thing you should notice is that all these combinations of labor and capital give you 50 units of output. That means the same way in which one utility curve has the same utility along the same curve, the isoquant will have the same unit of output along the same curve. So let's get rid of these points now here. What we're saying is that this isoquant along every point is going to give you 50 units of output. Now, the last thing it should be clear to you is that if the amount of output increases, then the isoquant is going to move to the right, right? Because let's say you can actually produce more output if you want, and since the form of the production function is the same, every time you produce more output, what you do is you move to an isoquant that is farther away from the origin but keeps the same slope. And the same thing if you produce less output. And you can try this on your own. What you can do is you try to do the numbers again, and instead of being 50 capital, try it with 25. And just keep this curve in there, and solve for the same unit of capital, but this time for output of 25, and see what you find out, and see if in fact the isoquant is going to move. It should move inside. labor has diminishing marginal returns. And the same for capital. As you increase the number of units of capital, the slope is going to get larger in absolute terms because you will need more capital in order to replace a lot less units of labor. All right. So we are gonna. This is the curve we're gonna be using in order to study production. Now, another thing you should notice is that all these combinations of labor and capital give you 50 units of output. That means the same way in which one utility curve has the same utility along the same curve, the isoquant will have the same unit of output along the same curve. So let's get rid of these points now here. What we're saying is that this isoquant along every point is going to give you 50 units of output. Now, the last thing it should be clear to you is that if the amount of output increases, then the isoquant is going to move to the right, right? Because let's say you can actually produce more output if you want, and since the form of the production function is the same, every time you produce more output, what you do is you move to an isoquant that is farther away from the origin but keeps the same slope. And the same thing if you produce less output. And you can try this on your own. What you can do is you try to do the numbers again, and instead of being 50 capital, try with 25. And just keep this curve in there, and solve for the same unit of capital, but this time for output of 25, and see what you find out, and see if in fact the isoquant is going to move. It should move inside.
So this brings us to the end of that video. It was about, yeah, that's done, Rafi. So I hope you understood today's topic, and it will be more clear to you once you go through the textbooks which you all have. Okay, it will be much clearer, and it is advisable, and it's a request that you should go through the books once so that everything becomes clear to you. Okay, so we'll be meeting in the next class. Till then, it's bye, and have a great week ahead. Have a sound sleep. Enjoy yourselves. Take care of yourselves. Please fill the feedback form which you'll get at the end. And thanks for your time, everybody. Bye. Please read your textbook so that you can ask your questions in the next class. If you have any doubts with the topic, please clarify them. Okay? Alright. Bye. Thanks for your time. Good night. Take care. Please fill the feedback form. Thanks.